This example that we just looked at, comparing time to depth and time to pressure or depth to pressure, something we call a relation. A relation is really just a set of ordered pairs. So we're going to write that in. So a relation is any set of ordered pair talking about two variables that I can compare. And what we're going to go through here is how to represent it in different ways. So ordered pairs, remember that that's just a set of x and y coordinates. So if I take a look, I can see this same graph here that we talked about on the previous slide. All I did is go ahead and input some of the coordinate points on it. So we can see this space here matching what we talked about. Time is moving forward. Time is on my x-axis. So I have 6 minutes and then I have 9 minutes. So time is going, but my depth is the same. I'm staying at 20 meters. Again, because we talked about staying put, we're not going higher to the surface, we're not going lower, but time's going to continue to move on. So when I'm talking about a relation, again, just comparing two variables and seeing what they look like on the graph, we have a couple different ways to represent it. The set of ordered pairs, a table, and then a mapping, which is what we're going to talk about that you probably are not too familiar with. But to start, ordered pairs, recall that that's just your set of coordinate points. So the first way we can represent a relation is by just listing out the coordinates. So I have 3 minutes, you're 10 meters. At 6 minutes, you're 20 meters. At 9 minutes, you're 20 meters. And then at 20 minutes, you're 45 meters down. Okay? Just representing it in the coordinates. You could also show a table. A table would just be listing your x and y coordinates separately. So my x coordinates, again, I am at 3 meters, and then I'm at 6 meters, 9 meters, and 20 meters. I'm sorry, minutes. Your x is your minutes. Talking about your depth, now I'm going to list out their y coordinates. So I went from 10 meters to 20 meters to 20 meters, and then at 45. You can also show it in the graph, which is what we have here. We're going to spend a lot of time focusing on graphs tomorrow and Wednesday. We're going to do some really cool Desmos activities where we're looking at these graphs, investigating the variables, and explaining how we can use graphs to represent situations like this, where they're kind of unconventional. So these flat portions of the graph, what's happening there, and really diving into the x and the y coordinates and what is happening on each axis at a given time. So again, we have our ordered pairs. You can represent a relation in a table, or you can represent it in a graph. The last way we can represent a relation is with a mapping. So we have two new vocab words here that you may not be familiar with. We have the domain of a function or a relation, and we have the range of a relation. The domain is just a fancy way to say, well, list all of your x values. And the range is just a really fancy way to say, well, let's just list all of our y values. Okay? But what's important here with the mapping that is not the same about these two is that whenever we're showing a mapping of a relation, we do not have to repeat any numbers. So what that means, if I'm listing the domain of my relation, your domain is just your set of x values. So my domain in this situation is the time. So I'm going to go ahead and list all of those values. So I had 3 minutes, I had 6 minutes, I had 9 minutes, and then I had 20 minutes. My range is just my set of y values. So the range in my relation, that's your depth. I'm going to go ahead and list all of my values here. But keep in mind, whenever we're creating a mapping of a relation, you don't want to write in any repeat values. So how I can see my 20 doubling up in my table and my 20 doubling up in the ordered pairs, as well as in the graph. When I list it in my mapping, we're going to represent it a little bit different. We're not going to represent it as that double number. So I'm just going to go ahead and list, I have 10. I am also 20 meters, and then I'm 45 meters. So when you're listing your domain and your range, you want to go from lowest to highest, and you do not want to write anytime a number shows up twice. Okay, we're going to represent that repeating value a little bit different. So your mapping, once you have your numbers listed, you're going to go ahead then and you're going to actually map and draw arrows from the domain to where they belong in the range. So at 3 minutes, I was 10 meters below surface level. So my 3 maps to my 10. At 6 minutes, I was 20 meters. And then at 9 minutes, I was also 20 meters. And then at 20 minutes, I was 45 meters. So it's just a different way to represent your relation. And we can see that overlap in depth showing up in a different manner. Here, I can see that overlap happening as my flattened portion of the graph. I can see that number repeating in the ordered pairs. I can see the number also repeating in the table. Okay, we're going to talk about a little bit on the next slide some patterns we can see and how that repeating value shows up and affects it. And then I see that repeated value showing up because I have two arrows pointing to the same value. On Friday, whenever we move into the next section, we're going to talk about functions and what makes something a function. And understanding your mapping and how to draw these arrows in is key for that. So anytime I have that repeated value, I'm not listing the number twice. I'm drawing my arrows pointing to the same number. So at 6 minutes and 9 minutes, I am at both of those times, I'm 20 minutes below sea level. Okay. So there you have it. That's your different ways to represent a relation. Again, ordered pairs, table, graph, domain, and range. On the next page, I'm going to ask you some questions to get you to start thinking about this table and what happens whenever we see that repeated value showing up.